Dear students, I am Sri Raji Narayanan, Assistant Professor from Computer Science and Engineering Department. This semester, I am going to handle the subject CS 305 Microprocessor and Microcontrollers for you. This is the syllabus. The prerequisite of this course is Computer Organization Architecture, that is already you studied in your previous semester. The course objectives are first one, to understand the internal organization of A0A6 microprocessor and A0A51 microcontroller. And in this course, we are introduced the concept of interfacing microprocessors with external devices, and also to develop assembly language programming skills. After the completion of this course, you will be able to describe the different modes of operations of a typical microprocessor and microcontrollers, and you will be able to design and develop A0A6 assembly language programs and interface microprocessors with various external devices, and you are able to analyze and compare the features of microprocessors and microcontrollers, and you will be able to design and develop assembly language programs using A051 microcontrollers. The textbooks are used here: Advanced Microprocessors and Peripherals by Burchandi and Ekerai, and Architecture Microcontrollers, Architecture Programming and Interfacing and System Design by Raj Kamal, and Microprocessor and Interfacing by Douglason V. Hall. Some references books are The Intel Microprocessors by Barry Bibre and Microprocessors and Microcontrollers by Nagurgani. There are 6 modules in this course. First module describes the evolution of microprocessors and the A0A6 microprocessor and its organization, and the main difference between the A0A6 and A88. In second module, it explains the addressing modes and instruction sets of A0A6. Then third module explains the interrupts and different types of interrupts and how interrupts are handled by the A0A6. Then in the fourth module, mainly it deals with the interfacing with memory, how processors are interfacing with I/O devices, and how it interface with the external devices. And fifth module includes the microcontrollers and what are the different types of microcontrollers and its application example, and explain the detailed diagram of A051 and its blocks. In the sixth module, we are explaining addressing modes and different types of instruction and programs used in A051. Then before going to our syllabus, I am just introduce some of the terms. First, what is a microprocessor? You are all heard about microprocessor. What is a microprocessor? It's one of the important components of a digital computer. So it's also act as a brain of the microcomputer system. So we know that as technology has progressed, microprocessors have become faster, smaller, and it can capable of doing more works per a clock cycle. So it's written as a mu p. So microprocessor is a controlling unit, or it's also known as a CPU of a microcomputer. Is integrated on a small chip, and it can perform ALU operation, and it's also communicate with the external device which is connected to it. So here I am going to explain the computer. Here what are the main components of a computer? Computer consists of input unit, output units, memory, and a central processing unit. In an input unit, in input unit, we are passing from the input unit that accepts the data from the user through either keyboard or any other input devices. That accepted data from the input unit is given to the memory. So, or either it is directly given to the CPU. So what is the main function of a CPU? CPU stores the data and set of instruction that is supplied by the user. And what is the function of a CPU? CPU processes the data that are accepted from the input devices, and it processes this data according to the instruction given by the user. And what is an output unit? Output unit is store the result that after the completion of a process, the process is done, processing of data is done by the CPU. After completion of that process, the result will be transferred to the output unit. So it communicates the result to the user or store it the result for future reference. So what are the main components of a CPU? Timing and control unit, ALU, and the registers. So already we told that CPU is the heart of the computer. So it fetches the instruction and data from the input devices and performs some arithmetical and logical operation, and it also controls the operation of all other units. So the main components of this CPU are arithmetic and logical unit, timing and control unit, and registers. Then arithmetic and logical unit perform the all arithmetical logical operation. Arithmetic means addition, subtraction, multiplication, division, etc. Logical operation means and, or, XOR, NOT, etc. These operations are done by the arithmetical and logical unit. What are the functions of a timing and control unit? The word, it generates the timing and control signal. This unit interprets the instruction given by the user, and it generates the various timing and control signal, and it controls the entire operation performed by the system. So it controls the operation of ALU, input output unit, and memory unit. If sometimes the user need to read a data from the memory, then it generates the control signal is memory read. If sometimes processor need to write the data to the output device, then it generates the control signal named IO write. So it write to the output device. Likewise, it generates the control signals. The next one is registers. Registers are the very first computer memory. It's reside in the CPU, so it is used to execute the program and operation efficiently. So it's a faster memory, and register means it can also hold instruction, data, address. That means it can store the data and instructions and addresses. So some cases, some instructions specify the registers as a part of the instruction. For example, we are using some instruction like add A comma B, add AX comma BX. This is one of the instruction. Here we need to perform the operation addition. Add means abbreviation of a addition. So add AX comma BX. Here AX is a register, BX is also register. So here it containing a data, AX and BX containing the data. Add operation indicate that add the content in this AX and BX, and result will be stored in the AX register. If AX containing 5 and BX containing 3, then it will be added 5 plus 3 and result 8 will be stored in the AX. This is the instruction. So this one is one of the instruction, and that instruction uses registers. Then next one is memory unit. Memory unit is used for storing data, whatever supplied by the input devices, and is also store the output devices. So CPU always connected to the memory through a bidirectional bus, and it take the data from the memory and also perform some operations in the ALU and result will be transferred to the output unit as well as to memory if we store that data into the memory for future use. So next term is microcomputer. Micro means small. Computer is a computer. So small computer. What is meant by microcomputer? If a computer with a microprocessor as a CPU, then it is known as microcomputer. Here, instead of CPU, if we use microprocessor as a CPU, then it is known as microcomputer. So example of a microcomputer is desktop computer, laptop, notebook or palm top. So in normal term, we are generally microcomputer is known as personal computer. The next one is multi-processor system. What is meant by multi? Multi means more than one. So more than one processor in a system. Then that system is called as multi-processor system. What is the advantage of a multi-processor system? If there is a more than one processor in a system, then it is a powerful computer. So if we use a supercomputer or a mainframe computer or high-ended powerful servers, then that type of computer containing multiple processors. That is, it can process more data at a single time. So it means it is very fast. The next one is microcontroller. Microcontroller is also a chip. That chip containing the components central processing unit, RAM, ROM, IO ports and timers. In a microcomputer, it's only containing, in a microprocessor, it's only containing a CPU. But in a microcontroller, it containing the memory like RAM and ROM and IO ports and timers, also CPU. So it's mainly used for special tasks, or it is used for a specific task to control a particular system. For example, washing machine. Washing machine we are using only for washing. So is microcontrollers mainly used for a particular operation or specific operations. So microprocessor, but microprocessor is used for a general purpose computers. That is the main difference between microprocessor and microcontroller. Microcontroller is a general purpose device, but microcontroller is a special purpose device. So microprocessor, already told that, is a central processing unit that is built on a single IC or a integrated on a single IC is known as microprocessor. And in this microprocessor, we are using a large scale integration ICs. The main function of a microprocessor is it fetch or get the instruction from the fetch the instruction stored in the main memory and identify the operation and device involved in it, and accordingly generate the control signal to determine when a given action is to take place. So what are the main function of a computer? The main function of a microprocessor is fetch the instruction and data from the memory. Memory contain the all the data and instruction. So fetch that instruction and data from the memory, and it placed into the arithmetical logical unit. Then arithmetical logical unit identifies, or CPU identify the operation. According to that operation, it generate the control signal. That control signal control the all the operation. Then according to that control signal or the instruction given from the memory, it performs some operation, and after that operation it will store the result into memory or it will given to the output devices. Then next, what are the main characteristics of a microprocessor? These are the some terms we are used in a microprocessor. Instruction set, bandwidth, clock speed, word length, width of a data bus, width of address bus and data types. Instruction means is a set of instruction that a microprocessor can understand. Here in 8086 already all instructions are given. In next, bandwidth. Bandwidth means the number of bits processed in a single instruction. Then width of the data bus. What is meant by bus? Bus carries the passengers. In normal bus, bus means bus carries passengers. Here data bus means bus carries the data. So here width of the data bus means it indicate the size of the data bus. Size of the database means how many number of bits can be transferred through the database. Next one is width of the address bus. Here it specify the number of bits that can be transferred through the database. The another main advantage of address bus is memory address capability of microprocessor is decided by this address bus. That is, the maximum size of the memory unit is decided by the address bus. If address bus size is 2, then how many memory can be accessible? 2 raised to 2, that is 4. If we use a 2-bit means 0, 0, 0, 1, 1, 0, 1, 1. So 4 address can be accessible. So address, using the address bus, we can identify the number of memory can be accessible. Then database, we can handle different type of datas like binary, BCD, ASCII, unsigned or signed numbers. Then next one is clock speed. It determines the number of operation per second the processor can perform. So how many operation can be performed in a second, that will be determined by the clock rate. So it is expressed in terms of megahertz or gigahertz. Here faster the clock means more instruction can be executed by the CPU in a second. So next one is word length. It depends upon the width of the internal data bus registers ALU. So if we say that A0, A6 is a 8-bit processor, or A0, 85 is a 8-bit processor, that means it can process 8-bit data at a time. So the processor have longer width, then it is more powerful, or it can process data at a faster rate. That is, if a processor has a word length 32 bit, that means that processor can process the data 32-bit data at a time. So if that is more faster than the 8-bit processor or a 16-bit processor. So what are the main features of a microprocessor? There is low power consumption. Mainly these microprocessors are manufactured by MOS technology, that is metal oxide semiconductor technology. The main feature of MOS technology is low power consumption. So next is versatility. Microprocessor is versatile. That means here microprocessor, we can use the same chip in a number of applications by configuring the software program. So same chip is used for different application. We need to alter that software program. Then we can use the same microprocessor for different application. Then next is reliability. So failure rate of an IC is in a microprocessor is very low. So it's more reliable. And its size is, microprocessor size is very small, so we can portable, means we can take from one location to another, and it's also cost effective. It is a low price, so it's cost effective. That's all today's section. Thank you.